Hello, math students. All right, back to 3D geometry, and today we're moving on to the last section of this unit. We've done, as a recap, some basics, gone over the vocab that was necessary for this unit. You've done well with that. We've done surface area of all types of shapes. That was a large focus of last week. And to kick off this week, we're going to be moving to volume. Today we're going to be talking about volume of rectangular prisms in particular, and then we'll be doing other shapes going forward. But first off, what is volume? Previously, I gave you an example of a cereal box, and we used that to discuss what surface area is. We said that surface area, as it pertains to a cereal box, is if you could lay that cereal box out flat. It's where all of the writing is on the box, the pictures, the name of the cereal, the nutritional facts, etc. Volume, on the other hand, is how much stuff fits inside the box. It's the amount of space that's inside that prism, that rectangular prism. Like if you could fill it all with cereal up to the tippy top, how much space could be filled with cereal? So volume is the amount of space that a three-dimensional figure takes up, and we're going to calculate today, or talk about how to calculate the volume of prisms. I would like you to file away this formula. This formula will work for any prism, the volume of any prism. And that formula, all right, any prism. So volume, that's too big. Let me start again. Volume is equal to the area of whatever the base is multiplied by the height of the actual prism. And I'm going to write that out in words so that you have it. There is your formula written out in words. So for any prism, rectangular, triangular, blah, 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 any prism, you can find its its volume, by first finding the area of whatever shape the base is, and then multiplying that number by whatever the height of the actual prism is. And the height is going to be the measure that goes from one base to the other base. So for rectangular prisms today, volume is going to be equal to the area of the rectangular base, multiplied by the height of the prism. And you can find the area of a rectangle by doing length times width. So let's jump to an example. It's oftentimes much easier to see things when you're working with actual numbers and actual shapes. Woo, we're going to work with fractions first. So in this green rectangular prism, I'm going to start by outlining the base. The base is a rectangle, and it's a rectangle that has dimensions of 7/8 meters by 1/2 meter. So volume is equal to the area of the base multiplied by the height. And you'll notice I'm using a capital B for area of the base. That's not unintentional or a mistake. Anytime you see a capital B in a geometric formula, it stands for the area of the base of whatever shape you're dealing with. In this case, I'm dealing with a rectangular prism. All right, so in this shape, the base, as I said, is a rectangle, and the rectangle is length times width, which is 7/8 times 1/2. So that's the area of the base. And the height of this prism is from one base up to the other, straight distance, which has to be 5/8. So times 5/8. And that's it. Now we just have to do some simple multiplication, and that will get us to our volume. So 7/8 times 1/2 is 7/16. And then I'm going to do 7/16 times 5/8. So that's going to get us to 35 over 128. And there you have it. Our final volume is equal to 35 over 128 meters. And look at this, pay attention, it's meters cubed. Why? Because volume is a three-dimensional measure that we are finding. We're multiplying three different things in this problem. We're doing the length of the rectangle by the width of the rectangle multiplied by the height. We're multiplying three things, meters times meters times meters. That's why when you see volume, the units for any shape volume is going to be meters cubed or inches cubed or feet cubed. It's always cubed to the third power. So there's the volume of a rectangular prism. I'll do a couple more examples just for the sake of showing, but they're all pretty much the same. They're all going to follow the same exact formula. Volume is equal to the area, the area of the base multiplied by the height of the actual prism. This is a cube, so all of the dimensions are exactly the same. 3 over 2 times 3 over 2 times 3 over 2. So the base is a square, length times width, 3/2 times 3/2, multiplied by the height, which is also 3/2. So my final volume is 3 times 3 is 9, times 3 is 27, over 2 times 2 is 4, times 2 is 8. And this time we're dealing with inches, and it's inches cubed because all volume is going to be whatever the units are, cubed. And our final example, I decided to give you something a little bit of a twist. This is asking you to find the missing measure where you already know the volume. Now this is interesting. Volume is equal to the area of the base times the height, but in this case we don't know the height. That in this picture is missing. We do know the base shape and we do know the volume, and I think you all are capable of doing this. It just takes a little bit of extra thinking. So the first step, step one, always plug in what you know, substitute in what you know. So I know the volume is 1,792, and I know the area of the base is 16 times 7, so I can fill 16 times 7 in. What I don't know is the height. That's my unknown measure, and I'm going to find that. So 16 times 7 is 112 times h. So now I know that 112 multiplied by something, some unknown height, should get me to 1,792. And if you can think back to units we have done before, you can certainly do this with inverse operations. The inverse of 112 times h is to divide by 112. So what am I going to do to the other side? I'm going to divide by 112. And when I do that, that gets rid of 112 on this side, and on my other side, it leaves me with my final my final height, of 16. So that tells me, and that's a fairly reasonable answer. Based on this image here, 16 seems totally reasonable. So the height of this computer tower is 16 inches tall. And there you have it, folks. Those are all the types of volume of rectangular prisms problems you might see today. As you go through your practice, make sure you take your time, show your work, and if you get stuck, go back to this video, rewatch, pause, do whatever you need to do, but regardless, have some fun! See ya!